Welcome back. In the previous video, we learned about the formal definition of cloud computing. Now it's time to look at the AWS and understand how the AWS cloud computing platform is designed. So let's start with the AWS About page. Here it is. We already learned what cloud computing is. However, if you want to know how AWS defines cloud computing, you can visit this link for what is cloud computing. Let me quickly go there. Great. So they give you a written definition and you can also play this video. This is a 3-minute video and I recommend that you watch it once. The NIST definition of cloud computing is the most elaborate and it is well accepted in the industry. However, you must also notice this pay-as-you-go pricing offered by AWS. We will discuss more when we learn about AWS pricing and billing. But I wanted to bring you on this page so you can spend 5 to 10 minutes here and understand what AWS says about cloud computing. Great. Let's come back to the AWS About page and start talking about the main subject of this video. AWS Cloud Global Infrastructure. That's what we want to understand in this video. In the cloud computing definition, we learned about the pool of resources, right? We learned that the cloud service provider must create a pool of resources. These resources are nothing but computing servers, storage servers, network devices, etc. AWS created its pool of resources across the globe, and that's what they define here. Let's try to understand it. AWS created hundreds of data centers across the globe. And within each data center, they installed hundreds of physical servers, storage servers, network devices, power management and backup systems, cooling systems, physical security, and many other things. These hundreds of data centers are grouped and classified using the following terminologies. These 5 terms are crucial for anyone who wants to understand how AWS data centers are spread worldwide. The smallest unit is a data center. An AWS data center may be as small as 5 to 10 servers, or it may be as big as few hundred or thousands of servers. AWS started to create these data centers in different geographical regions. Here is the map that shows 24 geographic regions around the world. This is the list of regions as of date. In the coming days, you will see AWS adding some more regions. For example, AWS created some data centers in the Mumbai region. Now they are building some more data centers in the Hyderabad region. So each region may have multiple physical data centers. But these physical data centers are again grouped in logical data centers and named as availability zones. Here is the diagram that helps you to understand this notion. So this diagram shows one region. Let's say it is the AWS Mumbai region. Within the Mumbai region, they went to 3 locations and created physical data centers. These 3 locations are often a few kilometers apart. AWS never shares the exact location of its data centers for security reasons. However, we know that they have data centers at 3 locations in the Mumbai region. AWS calls these locations as availability zones. So, we know that the AWS Mumbai region is built using 3 availability zones. All these 3 availability zones are interconnected with high-speed microfibers. Each zone has got its own power supply. So, if you have a power supply failure or lightning strikes or tornadoes in one availability zone, the other zone remains unaffected. Each zone may have one or more physical data centers. These data centers in one zone are often side by side or on different floors of the same building or within the same physical premise. So, physically, you may have one or more data centers in an availability zone. Each data center in a single availability zone often has its own power backup and networking equipment. So, power failure or network failure in one data center may not affect the other data centers. However, a power supply interruption in the area or some other turbulence affecting the whole area might impact the complete availability zone and disconnect it from the network. Make sense? Great. I hope you now understand the AWS region and availability zone. Now we are left with 3 more categories: local zone, wavelength, and outposts. These three are extension data centers. Let's try to understand them. AWS local zone is an extension data center of an AWS region. For example, AWS launched the Northern California region in 2009. They created 3 availability zones in the California region. However, later, they identified a more significant demand from the Los Angeles area due to greater population, industrialization, and concentration of IT centers in the area. So in 2019, they created data centers in the Los Angeles area and named it the local zone. These local zones are similar to availability zones, but they are too far from the region. I mean, the California region has got 3 availability zones, and all of them are nearby a few miles. However, Los Angeles is a few hundred miles away from the Northern California region. But Los Angeles local zone is connected to the California region. Make sense? Great. Local zones are designed to extend a region to a few hundred miles if there is a greater demand. Now let's try to understand the wavelength zone. Wavelength zone is a specially designed data center for 5G networks. AWS is creating wavelength zones inside the telecom provider's data center at the edge of the 5G networks. So, if your application traffic is coming from 5G network, it can reach application servers running in the wavelength zone without leaving the mobile provider's network. Make sense? So, a wavelength zone is a mini data center zone embedded in the 5G telecom provider's edge data center. Right? Great. The last one is the outpost zone. The outpost zone is a data center that is designed to bring AWS cloud to the on-premise. What does it mean? Simple. Let's assume my organization wants to use AWS cloud and its services. However, we do not want our data to go outside the company premise. I talked to AWS and they agreed to set up an outpost data center in my company premises. I am not setting up an on-premise private cloud. Instead, I am going to get an AWS data center inside my premise. I'll be using AWS servers, AWS services, and AWS technology. All of this will be managed and supported by AWS. Still, my data and my application will run from inside my company premises. This arrangement is often categorized as hybrid cloud infrastructure because your organization infrastructure is seamlessly integrated with the AWS cloud outpost. Make sense? Great. Now we know different types of AWS data centers, how they name them, and what it means. This knowledge goes a long way and helps you make the right decision to design and select AWS infrastructure for your applications. We end this session here, but we will learn more about these concepts and their role in decision making as we progress with the course. Great. See you again. Keep learning and keep growing.